This is the kind of bug that sends people in circles. A method crashes. The values look impossible. Nothing nearby explains the future. You scroll, you search, you add logs. Eventually someone says, "This code worked before." What makes these bugs hard is not complexity. It's distance. The failure happens long after the mistake. The calls already ran and disappeared. This video is about that moment. Not loops, not conditionals, but the execution that happens exactly once, during construction, and quietly defines everything that follows. A constructor is not a configuration phase. It's not declarative. It's execution, real instructions, running on the CPU, mutating memory. When the constructor finishes, that execution is over permanently. There is no retry. There is no later fix. Whatever state exists at that moment becomes a starting point for every future method call. That makes construction unique. It's the only execution that defines an object's entire lifetime before anyone else can touch it. This code looks harmless. No nulls, no conditionals, no logic errors. But it produces a permanently wrong object. Why? Because these lines execute in order during construction. When limit is computed, size still holds its default value. The CPU is not confused. It followed the rules exactly. The bug is temporal. A value was read before it existed. Once limit is set, it is never recomputed. The object leaves construction already corrupted. This kind of bug survives refactors because nothing looks wrong afterward. You can rename variables, extract methods, add comments. None of that changes the fact that the wrong value was computed once and stored. Every method that runs later inherits that state. The constructor is no longer on the stack, so the failure appears unrelated. That's why people misdiagnose these bugs as weird behavior instead of construction errors. Methods usually assume the object is valid. During construction, that assumption is false. Fields may not be initialized yet. Subclass state may not exist yet. Calling a method from a constructor executes logic against incomplete state. Sometimes it fails immediately. More often, it fails later, after overrides, callbacks, or state changes. The method isn't wrong. The timing is. Here, the object escapes during construction. Other code can see it now. Call methods on it. Trust it. But construction hasn't finished. Some fields may not exist yet. Some invariants are not established. The failure doesn't happen here. It happens later, when another execution path assumes the object is valid. By then, the constructor is long gone. Different failures, same root cause. An object existed in a state that should have been impossible. Once that happens, the system is compromised. Every method call assumes validity. That assumption was broken at birth. This is why construction bugs are difficult to trace. They violate trust early and explode late. Comments describe intent. Tests observe outcomes. Neither prevents invalid state from existing. If an object can be constructed incorrectly, eventually it will be. Not because people are careless, but because systems evolve. Construction is not a place for reminders. It's a place for enforcement. During construction, the object is private. No other code can see it. No methods should run. No references should escape. This is the only moment where you fully control state without interference. Once construction ends, that exclusivity disappears forever. The rule is simple. Build all required state, validate it, then expose the object. No methods, no callbacks, no escape. This isn't style. It's respecting execution order and state lifetime. All dependencies exist. Order is clear. State is born valid. Nothing runs early. Nothing escapes. This object enters the system already trustworthy. Once you see construction as execution, design flips. You stop patching state later. You stop trusting comments. You stop calling methods too early. Do this, and you work on new features. Ignore it, and you're putting out bug fires. That's the rule to carry forward. If an object exists, every method will trust it. Construction is where that trust is earned.